So if you are done, let's listen up. So we'll be looking at standard Gibbs free energy. Standard Gibbs free energy. Now, in the previous things we've done, we've seen Gibbs free energy. But now let's look at standard Gibbs free energy. Now, standard Gibbs free energy, change in standard Gibbs free energy is given as delta. If we write only delta G, this is what? Change in Gibbs free energy, right? Then if you add naught here, this is now standard change in Gibbs free energy. Do we get? Without this naught, it is what? Change in Gibbs free energy, right? But with this naught, it is standard change in Gibbs free energy. Now, standard change in Gibbs free energy is the Gibbs free energy, change in Gibbs free energy in standard state. Standard state is defined as when the reaction is taking place at a pH of what? 7, and all the reactants are in a concentration of what? 1.0 what? Mole per liter, right? If all the reactants are present in 1.0 mole per liter, pH of 7 and temperature of what? 273 Kelvin, then we say the reaction is occurring in a standard state. But most times in nature, reactions are not always occurring in standard states. pH is not always 7. The reactants are not always in 1 mole per liter. Temperature is not always 273 Kelvin. So, if the temperature or the pH or the reactants are not in these concentrations or not these values, then we'll just be looking at delta G. But if everything is in this standard state, we'll look at delta G naught, right? But since it is not always so, things are not always standard, how do we relate the standard and the one that is not standard? Delta G naught that is standard and delta G naught that is not standard. They are related with the formula delta G equal to delta G naught plus ROT ln K. Now, please, I'll beg you to listen attentively here. Now, delta G is changing Gibbs free energy, right? Delta G naught is what? Standard change in Gibbs free energy. Now, R is what? Gas constant, right? R is gas constant, and you know that the value of R is what? 8.314 joules per mole Kelvin. This is R. Now, T is temperature in Kelvin, is it not? Then ln K. K here is what? Reaction quotient, or you call it equilibrium constant. Equilibrium constant. Now, equilibrium constant, if you have a reaction like this, A plus B, so give C plus D, and you are asked to write the reaction quotient or the equilibrium constant, the equilibrium constant will always be given as the concentration of the product all over the concentration of the what? Reactants. So you'll be having concentration of the products, but you take note of this stoichiometry. It will now be raised to the power. So here, concentration of the products T all over the concentration of the reactants. So this is how K is calculated. So most times in calculation, they will give you the concentration of the products and give you concentration of the reactants. So get K, just do concentration of the product all over concentration of the reactants. You've gotten K. But now, have you written this? If you are writing this, please write it. Let me, or just follow me. Now, we said something before, that if delta G is equal to 0, we said the reaction is what? If delta G is equal to 0, the reaction is what? At equilibrium, right? At equilibrium. Now, if the reaction is at equilibrium, it means delta G is equal to 0, right? Please stop writing and listen up. I'll give you time to write. If delta G is 0, we say the reaction is at equilibrium. So if the reaction is at equilibrium, it means in this equation here, at equilibrium, it means delta G here will be 0, right? Because at equilibrium, delta G is always 0. So at equilibrium, it means here will be 0, right? Equal to delta G naught plus ROT ln K. Is it not? Now, if I want to make delta G naught the subject of the formula, what will I get? Delta G naught will be equal to what? Minus what? Because this one is coming here now, minus what? ROT ln K. Now, you can use this in your calculation, but in mathematics, ln K, ln is on your calculator, is it not? Ln is on your calculator. And it's related to log. In mathematics, if you want to change ln to log, it is standard that if you want to change ln to log, that is, if you want to remove ln here and put log, what I'll do is what? I'll multiply by what? 2.303. Mathematical standard. I did not introduce anything. So if you want to change ln to log, you do what? You put what? You multiply by what? 2.303. Standard. So if I want to remove ln here and put log, I'll multiply by, my minus is still there, 2.303, then ROT what? Log K. If you use this formula, you are correct in solving. If you use this formula, you are still correct in solving. So you can use any of them and you'll be correct. So basically what we've done, we've seen how delta G relates to delta G naught. So delta G is equal to delta G naught plus ROT ln K. But if it is the reaction is at equilibrium, we will know that at equilibrium, delta G is equal to what? 0. So if delta G is equal to 0 at equilibrium, we'll have this. We'll make delta G naught the subject of the formula. And this is it. So we'll be using this in calculation subsequently as you go on. So you can write this down. Now let's solve this together. The question says, example 1, the question says, hydrolysis of glucose 1-phosphate at 27 degrees Celsius has a standard Gibbs free energy of minus 10.7 kilojoules per mole. Calculate the equilibrium constant of the reaction below. And we're given the reaction glucose 1-phosphate plus water to give glucose plus pi. Now solution. Just like I always say, the first thing you have to do when you have an equation like this is to write the parameters you were given. Now here we are given temperature as what? 27 degrees Celsius, right? And you have to convert it to Kelvin, is it not? And we already know that converting it to Kelvin, you add 273. So our answer here is what? 300 Kelvin. What else were we given in this equation? We're given standard Gibbs free energy. And you know standard Gibbs free energy is delta what? G naught. Was given as what? Minus 10.7 kilojoules per mole. And what else are we given? We're asked to calculate the equilibrium constant of the reaction, right? Equilibrium constant is what? K, right? Now, if this is kilojoules per mole, if we convert it to joules per mole, we'll be multiplying by what? 1000, right? So this will be minus what? 10,700 joules per mole. Alright. Now, if you look at this very well, we're given T. We're given delta G naught, and we're asked to calculate equilibrium constant. Which formula do you think we can use? Delta G naught. The best formula to use is delta G naught equal to minus what? ROT ln K. I know this, if you want to change it to log K, we'll just multiply by what? 2.303, right? So this is same thing as saying delta G naught equal to minus 2.303 ROT log K. But just like I said, any formula, anyone you use, you are correct. You use this one, you get it right. You use this one, you also get it right. Now we are seeing arrow here, and arrow is gas constant, and the value of arrow is what? 8.314 what? Joules per mole Kelvin. All right. Now you've stated your parameters, you've stated your formula. The next thing is to substitute. What we are looking for is K, right? Is it not? Now, if we substitute, let's use the second formula. If we are using the second formula, let's make log K the subject of the formula. If we make log K the subject of the formula, it means we'll be dividing through by the whole of this, right? Are we together? We want to make, because we are asked to calculate K, we can make log K the subject of the formula, right? And for us to make log K the subject of the formula, you divide through by the coefficient of log K, everything by the side of log K. So if you divide through by log K, you'll be having log K to be equal to what? Delta G naught over what? Minus 2.303 ROT. Right? Do you understand? Now, log K now will now be equal to delta G naught was given as what? Minus 10700 all over now minus 2.303 times arrow is given as what? 8.314 times T is what? 300. So we'll have it that, can I clean this? So we'll have it that log K, I don't know how many times I will refill this marker today. So we'll have it that log K is equal to minus this over, now calculate everything down for me to give you what? Minus what? 5744 1426. Good. Now log K will be equal to, you agree with me that minus will cancel minus, right? So this divided by this will give us what? 1.862. Is it? 1. What? 1.8627, like that. No problem. We can leave it at that. Now we've gotten log K, but what were we asked to find? K, right? Not log K, right? Now to remove log, what do? You take the what? Anti-log. So K will be equal to the anti-log of what? 1.8627. So K will be equal to anti-log of that is what? For those of you that don't know how to press anti-log, anti-log is just shift log. Shift. You press shift, then you press log. That will give you anti-log. So anti-log of this is what? 72. What? 89. What's the unit? What is the unit? Equilibrium constant has no unit, so it is unitless. So the answer is this. This is our answer. You go your way. Now let's look at example 2. Calculate the standard free energy change of the reaction by phosphoglucomutase. And this reaction was given. Glucose 1-phosphate was interconverted to glucose 6-phosphate. Given that final equilibrium mixture in either direction will contain 1 millimolar glucose 1-phosphate and 19 millimolar glucose 6-phosphate at 25 degrees Celsius and pH 7. And I always say, anytime you want to solve, the first thing is to do what? Write the parameters that you are given, right? So the parameters given, we're given temperature. We're given temperature as what? 25 degrees Celsius. But we know we always convert the temperature to what? To Kelvin, right? So to Kelvin now will be 25 plus 273, which will give us what? 298 Kelvin. Now the next thing is, we were given what again? We're given the concentration, given that the final equilibrium mixture in either direction will contain 1 millimolar glucose 1-phosphate, meaning that the concentration of glucose 1-phosphate will be equal to what? 1 millimolar, right? And the concentration of glucose 6-phosphate will be what? Will be 19 millimolar. Now we were asked to calculate what? Calculate the standard free energy change. That's, we're asked to calculate delta G naught, right? But you agree with me that equilibrium delta G naught is equal to minus ROT, or let's use minus 2.303 ROT log K, right? Now this is same thing as saying delta G naught equal to minus 2.303 ROT times log K. You agree with me that K is same thing as the concentration of the product over concentration of the what? Reactants. And the product from this equation is glucose 6-phosphate, right? And the reactant is glucose 1-phosphate. So we'll be having concentration of glucose 6-phosphate all over concentration of glucose 1-phosphate. Do you understand what we did there? Now, delta G naught will be equal to minus 2.303 times R is gas constant. I will know the value of R is what? 8.314 joules per mole Kelvin. Now times our R is 8.314 times T is what? 298 times log. What's the concentration of glucose 6-phosphate? 19 over what's the concentration of glucose 1-phosphate? 1. So we'll be having delta G naught to be equal to minus 2.303 times 8.314 times 298 times log 19 divided by 1 is what? 19. So we have it that delta G naught will be equal to, please, to avoid long writing, this times this times this will give me what? Leave the log. This times this times this will give me what? Will give us what? Minus what? Press your calculator. Minus 570 minus 5705. One what? 848. Then times log 19 is what? 1.27. Now multiply everything for me. Delta G becomes what? Delta G naught becomes what? Multiply everything. Delta G naught becomes what? Minus what? Minus 7246 point what? 42. What's the unit? Joules per mole, right? But if you want to convert this to kilojoules per mole, if you want to convert it to kilojoules per mole, you do what? You divide by what? 1000, right? So that will be what? That will be what? 7.246 kilojoules per mole. If you leave your answer in joules per mole, you are correct. If you leave your answer in kilojoules per mole, you are correct also. Alright, so basically, this is how to go about this. Write it down.